the resin. Machine shop processes, after the motor's approved, it's been cleaned, it may go through various processes. Some cases, new parts are needed. Following are examples. So we have examples. This is a motor that came in with a wipe sleeve bearing. It took the seals out, and we're just going to focus a little bit on that again. Seals, documentation, pictures of the actual motor. I think it's the same motor we were looking at a minute ago. And you could see where the seals are wiped. And then manufacturing new seals out of raw material and manufacturing the seals. Right down to the fine details of putting in oil return grooves and holes so that when the oil gets into the Labyrinth seal, it has a way of getting out by returning back into the motor. Stop it. Labyrinth seals continued. Final machine sizes are then documented. So on this form, you have incoming again, and you have the repair method, and you have the final sizes. We like that because it's on one form. It allows us then to be able to see the whole activity of the repair in the mechanical aspect. Other methods of repair, we might chrome plate a shaft extension, and then that gets ground. Or we might repair cracks and frames, just showing some simple things that we might do. Of course, identifying the materials, making sure we're following the right weld procedure, really important. Sleeving a housing, very common for us to sleeve a housing of smaller motors, even larger ones. Boring out the housing, putting in the sleeve, shrinking the sleeve in, and then cutting it to the final size, to the bearing tolerance charts that are predefined by the bearing manufacturers. This is just a quick blurb. Some of them are blurry, but it's a shorting ring, a slotted shorting ring for a induction rotor. So identifying the alloy, machining it, and then cutting the slots in the shorting ring. Manufacturing a new shaft, starting with a print, just a quick fast track, machining it all the way down to close to the final, cutting the keyways. But here are the points, steps to manufacturing a shaft: make a shaft print, identify the original material. So the material will drill in the end of the shaft typically, and then we'll send those filings to a lab like this one, and they'll identify through the chemistry of the metal what we're dealing with. Was it 1040 steel or was it 4140 steel? What is it? So that either we can duplicate or we know what you had, and we recommend typically to put something a little better in it, like 4140. Rough machining the shaft to within 100 to 150 thousandths, but not finishing it, and then getting it stress relieved in a heat processing oven. Very important step. If you just turn that shaft down like the one that I showed, and you don't go through the proper stress relieving process, that shaft will look good today, and it will actually move in service. The stresses will relieve, and you'll end up getting a run out in the shaft.